Imagine yourself standing upon a vast beach at night, with gentle waves lapping at your feet, and above you stretches a canopy of stars, twinkling like grains of golden sand scattered by some immense unseen hand. Each of those stars is a sun in its own right, perhaps nurturing life on distant worlds far beyond our sight. Yet, a thought creeps into your mind, much like the whisper of the sea breeze. We, humanity, may forever remain confined to this galaxy of ours, not for want of endeavor, but because the immutable laws of the universe bind us with invisible threads. Not merely for 10,000 years or a million, but eternally. This notion might fill you with doubt, for our history is one of ceaseless advancement, from the first footsteps upon the earth to voyages across the boundless void. Allow me to unfold this tale for you, slowly, like a river winding through enigmatic landscapes, so that you may grasp both its wonder and its poignant melancholy. Let us journey back to the year 1969, when the Apollo 11 spacecraft successfully touched down upon the moon, traversing a distance of approximately 380,000 kilometers. That was a moment when the world held its breath. Applause echoed through living rooms, and children dreamed of reaching out to the stars. The astronauts walked upon that dusty surface, experiencing a profound isolation, with Earth suspended like a brilliant blue orb against the inky blackness. Then, in 1997, the National Aeronautics and Space Administration's Sojourner rover landed upon Mars, marking humanity's first contact with the surface of that red planet. The shortest distance between Earth and Mars is about 55 million kilometers, a figure that induces vertigo, as if gazing into an abyss. The initial images from that crimson, rocky terrain, with dust devils gently swirling, ignited hopes of a new home. More recently, as of 2025, the Voyager 1 probe continues its odyssey, having surpassed a distance of approximately 25 billion kilometers from Earth, venturing deep into interstellar space, where the light from our sun is but a faint glimmer. According to the latest updates from the National Aeronautics and Space Administration in 2026, Voyager 1 is approaching a distance of 1 light day from Earth, meaning that radio signals from it now take a full day to reach us, like an echo from a distant past. It seems as though we are venturing ever farther, does it not? Yet, if we liken the Milky Way to the colossal body of a human being, with its hundreds of billions of cells representing the stars, the distance Voyager has covered has not even pierced through a single minuscule cell. To render this more tangible, consider these figures as tales from a dark fairy story. At its current velocity of approximately 17 kilometers per second, to depart the solar system, specifically to pass beyond the Oort cloud, the outermost shell, would require about 300,000 years. But to escape the Milky Way entirely, according to calculations by astronomers such as those at the University of Pennsylvania, would demand around 2 billion years. The original accounts mentioned 1.6 billion years, but recent studies, including simulations from galactic models published in astronomical journals up to 2026, affirm that traversing the galaxy's diameter of about 100,000 light-years at such a speed could take 2 billion years or more, depending upon the direction of travel. 1.6 billion years ago, the most complex life on Earth consisted of single-celled organisms drifting languidly in primordial oceans, where sunlight filtered through salty waters, orchestrating the first dances of existence. 1.6 billion years hence, the sun will swell into a red giant, engulfing Earth in its final fury, reducing our blue planet to ash. Voyager 1, bearing its golden messages of humanity, the resonant music of Beethoven, the laughter of children, images of vast oceans, will never arrive anywhere, merely drifting silently through endless darkness, like a forgotten prayer. You might suppose this is merely a technical hurdle, that science will devise a solution. But no, this is a cosmic prison erected for every civilization, with 3 formidable walls sealing off all possibility of escape. The first wall is speed, akin to a motorway limited to 120 kilometers per hour, no matter how fiercely you press the accelerator. The universe's limit is the speed of light, 300,000 kilometers per second, sufficient to circle Earth 7.5 times in a single heartbeat. It sounds prodigiously swift, does it not? Yet, light from the sun reaches Earth in 8 minutes, like a belated greeting. To the nearest star, Proxima Centauri, it takes 4.2 years. To the galaxy's edge, 100,000 years. Even if you attained that velocity, journeying to the galactic rim would consume 100,000 years, a span in which civilizations might rise and fall, leaving ruins buried in stellar dust. You might ponder, what if Einstein were mistaken? What if the light barrier could be breached? But the general theory of relativity, promulgated by Albert Einstein in 1915, elucidates the relationship between mass and velocity. The faster you go, the heavier you become. As you approach the speed of light, a mere screw would weigh more than Earth. To achieve light speed, the energy required approaches infinity, like attempting to shift a mountain with bare hands. 119 years have passed, and countless experiments at particle accelerators such as the Large Hadron Collider at the European Organization for Nuclear Research have validated this. In such accelerators, protons are propelled to 99% of light speed, their mass increasing 7,000-fold. Global positioning satellites, if uncorrected for relativistic effects, would accumulate positioning errors of 10 kilometers per day, rendering world maps chaotic. The light speed limit is no idle theory. It is a harsh reality, like tempestuous waves no sailor can conquer. What then of engines that warp space, the so-called warp drive? That concept resembles a dream from science fiction, where space ahead is compressed and space behind expanded, allowing the spacecraft to remain stationary while space itself moves around it. In 1994, physicist Miguel Alcubierre computed a mathematical model for such a warp drive, and theoretically, it is feasible. But the crux lies in negative energy matter, a form of matter with negative mass, where gravity repels rather than attracts, equivalent to lending a friend 100,000 pounds only to find yourself inexplicably owing them 200,000 in return. Does this make sense? Over 70 years, no experiment has detected its trace, despite efforts by physicists at laboratories such as Fermi Lab. However, in 2025, a research team led by Dr. Jared Fuchs at the University of Alabama in Huntsville proposed a subluminal warp drive model operating below light speed, requiring no negative energy, employing established physical principles to create a stable space bubble. This has kindled fresh hope, though it remains distant, for the energy demands are still colossal, akin to harnessing power from a small black hole. Stepping back, even if negative energy existed, physicists have calculated that a 10-meter warp drive ship would necessitate negative matter equivalent to Jupiter's mass, a gas giant with perpetual raging storms. Thus, warp drive remains essentially a mathematical pastime for physicists, like theorizing one could become the world's richest by having 2 pounds flow into one's pocket for every one spent. Deductions from scientists such as Harold White at the National Aeronautics and Space Administration's Eagle Works suggest energy requirements might be reduced to the equivalent of 1 ton, but even that demands technology far beyond our current grasp. Discussions on scientific forums such as Reddit or X, formerly Twitter, from experts like Brian Greene emphasize that this remains a theoretical realm, replete with unresolved enigmas. Recent advancements in 2025 and 2026, including models from engineer Sonny White and colleagues at Casimir, have reimagined faster-than-light propulsion without exotic matter. Yet, practical implementation hinges on overcoming energy barriers and ensuring gravitational wave stability, as simulated in studies from the Max Planck Institute. The second wall is energy. Like a telephone with 1% battery remaining, yet you wish to stream videos all day. Regarding fuel for spacecraft, even incinerating the entire solar system would not suffice. This is no exaggeration. It is brutal fact. Based upon Einstein's mass-energy equivalence equation, energy equals mass times the speed of light squared, accelerating a 1-ton ship to 90. A minimally viable crude ship must weigh 100 tons, with living quarters, provisions, and medical apparatus, where machinery hums like a lullaby in the dark. Propelling it to 90% light speed necessitates the sun's energy output over 100 days. The sun consumes 630 million tons of matter per second, so 100 days equates to 5,443 million trillion tons. That is merely for acceleration. Upon arrival, deceleration is essential, lest collision at near light speed vaporize you like a meteor in the atmosphere. Thus, actual energy needs double, a magnitude that renders us diminutive before the cosmos. The most recent estimates from studies at the California Institute of Technology in 2025 confirm that even with advanced technology, interstellar travel energy demands exceed the harvesting capacity of a Type 1 civilization on the Kardashev scale. What if nuclear fusion? The optimal reaction converts only 0.7% of mass to energy. Propelling a 100-ton ship to 90% light speed requires astronomical fuel quantities, not accounting for the fuel's own weight, which burdens the ship like an overburdened traveler. Extracting all deuterium from Earth's oceans yields 5 billion tons. How many Earths would suffice? Antimatter, then? 1 gram annihilating releases energy equivalent to 40,000 tons of trinitrotoluene explosive. It sounds ideal, but the European Organization for Nuclear Research, operating at full capacity, produces 1,000th of a gram annually. At this rate, 1 gram demands 1 billion years, a span for empires to crumble and rise thousands-fold. Moreover, antimatter annihilates upon contact with anything, with no safe storage, though 2026 experiments at the University of Tokyo have tested magnetic traps. Solar sails? Fuel-free, propelled by light pressure, but light's thrust is feeble. At Earth's orbit, each square meter bears force equal to a sand grain's weight. Accelerating a 1-ton ship requires a sail 100 kilometers square, and farther from the sun, thrust diminishes, potentially stranding it within the solar system. The second brings restlessness, the clock's ticking grating. The third renders everything irksome, walls seeming to close in. The fourth leaves one feeling utterly diminished, the mind adrift in solitude. Imagine enclosure in a sealed space. Beyond the window, perpetual blackness, no twinkling stars, only machinery's whir and your own breath. Endure that for decades, and I dare not contemplate what you become, perhaps a specter wandering memories. In 2015, the National Aeronautics and Space Administration conducted the Hawaii Space Exploration Analog and Simulation, where 6 volunteers inhabited a sealed dome for 1 year. Initially, all brimmed with confidence, smiles radiant and handshakes warm. But by the 4th month, one succumbed to despair, sitting alone in shadows, tears streaming. By the 6th, 2 nearly came to blows over a disputed spoon, shouts echoing in cramped confines. By the 8th, one muttered to oneself, mental health fracturing like glass. By the 10th, the team fragmented, trust shattered like broken panes. And that was on Earth, with hope sustaining them, knowing endurance for a year brought release, sunlight awaiting beyond the door. True interstellar voyages span decades, perhaps eternally without return, an unbearable torment, like burial alive in a cosmic coffin. The latest research from the National Aeronautics and Space Administration in 2026 under the Human Research Program confirms prolonged isolation induces cognitive decline, sleep disorders, and heightened group conflict risk, with symptoms akin to severe depression, where stellar wind sounds become fear's whispers. Further studies in 2025 and 2026, such as the Crew Health and Performance Exploration Analog missions, have explored virtual reality nature therapy to mitigate mild depression in simulated space stations, showing promising reductions in isolation's psychological toll. What of hibernation or cryogenic suspension? The answer is no, at least with present technology. The core issue is ice crystals. As temperature drops below 0 degrees Celsius, cellular water freezes, sharp crystals piercing membranes. Upon thawing, you do not awaken, but dissolve into mush, like snow melting in spring sun. Venturing beyond the solar system in hibernation invites gradual radiation roasting, unless thick shielding is added, multiplying ship mass exponentially. What of generation ships, where successive generations live and die en route? Feasible, perhaps, but in vision. To maintain genetic diversity, at least 500 souls are needed, averting inbreeding deformities. Each requires 1 kilogram of food daily, 3 liters of water, 20 cubic meters of clean air. Add production facilities, medical bays with beeping monitors tracking heartbeats, education under artificial lights. The ship swells to city size, massing hundreds of millions of tons, adrift in darkness, with stellar winds murmuring outside. The energy to propel it? Back to the second wall, demands rendering it impracticable. Even if built, enclosing 500 humans, replete with love, jealousy, hope, despair, in a metal box for millennia, what ensues? The first generation knows the purpose, regaling offspring with tales of verdant earth. The third begins doubting, eyes wary over communal meals. To the 10th, Earth is mythic paradise, a bedtime fable. The 100th might regress to primitive tribes, rituals under dim lamps. A 2018 Cornell University study simulated societal evolution on generation ships, concluding that despite ideal starts, within 300 years, authoritarianism emerges with echoing slogans, religious fanaticism with shadowed prayers, wars with gunfire and bloodshed, population dwindles or collective suicide ensues, the ship a drifting tomb, silent and cold. Design contests like Project Hyperion in 2025 from the Initiative for Interstellar Studies proposed jellyfish-shaped models 36 miles long, housing 2,400 with artificial agriculture and polygamy for population stability. But simulations reveal social conflict as the paramount barrier, rendering the dream remote. Where then are the other civilizations in the universe? Enrico Fermi, the Italian physicist, posed that query in 1950 over lunch at Los Alamos National Laboratory. Where are they? The Milky Way harbors 400 billion stars, many with orbiting planets, conditions for life not rare, spreading like seeds in wind. Yet we detect nothing. No radio signals resounding, no probes gliding by, no traces of megastructures like Dyson spheres encircling stars. Why? Likely they too are imprisoned, each civilization confined to its galaxy, despairing before identical physical laws. Light too slow, like a tortoise crossing desert. Energy too scarce, like a drop in ocean. Life too fleeting, like a blooming then withering flower. They too wonder where others are, calculating distances, fuel costs, concluding, nowhere to go. We resemble prisoners in separate cells of a vast gale, glimpsing each other's flickering lights through cracks, but hearing no voices, the walls too thick, doors too heavy, locks too many. The search for extraterrestrial intelligence has scanned for 60 years, telescopes sweeping night skies, listening to silent frequencies, fruitlessly. Updates from the Search for Extraterrestrial Intelligence Institute in 2026 report expansions with new instruments, like the Square Kilometer Array, yet no signals, only the universe's murmur. Even if a signal arrived, a hello from Proxima Centauri, you reply, greetings, but perhaps miscommunication breeds war. Even comprehensible, one exchange takes 8 years, 100 queries, 800 years, civilizations perhaps supplanted, new empires rising from ashes. More ironically, the universe's timescale is immense, civilizations' lifespans brief.
The odds of two coexisting resemble finding a marked sand grain in the Sahara. Mostly, when you shine with technology and hope, the other has faded. When they shine, you are gone. As the saying goes, when the army is born, I am not. When I am born, the army is lost. New theories on the Fermi Paradox in 2026 from scientists like Robin Corbett at the National Aeronautics and Space Administration suggest extraterrestrial civilizations may exist, but be radically mundane, lacking wildly advanced technology, not expanding, but remaining on homeworlds, avoiding interstellar risks. Another, The Dark Forest from Lucy Sin, depicts the universe as a shadowy woodland where creatures stay silent to evade predators, revealing position, inviting doom. Or, per Oxford University research, complex life rarer than thought, bottlenecked by eukaryotic cell formation by endosymbiosis, host cell and bacteria merging, occurring once on Earth after 2 billion years. Nick Lane, biochemist at University College London, argues that across billions of Earth-like planets in the Milky Way, simple life may abound, but eukaryotic cells with distinct mitochondria enable complexity, solving respiration issues in larger cells. Without mitochondria, bacteria cannot expand without redundantly copying genomes, an enormous energy hurdle. Discussions on X from scientists like Jason Wright and Adam Frank highlight that ancient civilizations might dwell in the galactic core, with denser stars but higher supernova risks, deterring expansion to peripheries like ours. What then is the truth? The universe is not empty, but vast, like an ocean with islands separated by thousands of miles. Civilizations exist, but distant, sundered by unchanging physical laws. We are not alone, but eternally divided by those laws, like lost souls in the night. The most resigned aspect is that we can see them there. If the night sky were starless, perhaps we would not grieve so.
It is beholding 400 billion radiant suns, knowing life with dreams like ours may thrive there, that breeds unwillingness, a melancholic sorrow like waves upon shore. This is like opening a window for a lifer, letting him glimpse freedom, children frolicking, wind through leaves, laughter echoing, while he remains forever barred. Perhaps other civilizations do exist, but we are imprisoned in our galaxy, eternally unable to meet. We all gaze upon the same starry vault, posing identical questions: whence we came, whither we go, finding identical answers, then bowing heads, persisting on our diminutive planets, dreams flickering like embers in darkness. Yet humanity must nurture a spark of hope, as ancestors a millennia ago could not foresee descendants treading the moon, engines roaring and flags fluttering, or Mars, first steps on dusty red soil.
We cannot envision Earth a millennium hence. Perhaps then the solar system seems a mere grain in oceanic expanse, today's prison walls crumbling under new intellect's might. Let that curiosity propel you, for the universe brims with mysteries, awaiting our discovery, even from afar. Finally, I extend sincere and profound gratitude to all the scientists, researchers, and research collectives mentioned in this narrative, from Albert Einstein, whose theory of relativity transformed our cosmic view, Miguel Alcubierre with his inventive warp drive model, Enrico Fermi with his globally stimulating paradox, to teams at the National Aeronautics and Space Administration, the European Organization for Nuclear Research, the Search for Extraterrestrial Intelligence Institute, and scientists such as Nick Lane, Jared Fuchs, Robin Corbett, Jason Wright, Adam Frank, Harold White, and countless others who have contributed quietly. We cherish your persistent efforts, tireless sacrifices, and immense contributions to humanity's knowledge treasury, aiding our deeper understanding of our place in the vast universe, and inspiring future generations to explore its wondrous enigmas.